Hi, everyone. So we are going to review quiz 17. Our first question is an evaluation question. We are asked to evaluate sine inverse of 1. And then you always want to make sure you read the entire instructions because it's also asking for your answer to be in radians and within the interval of negative pi over 2 to pi over 2. So uh, let's zoom in on this. What is sine inverse 1 really asking us? It's just simply asking sine of what angle will give us 1. And again, between this interval, negative pi over 2 and pi over 2. So think about your famous angles. Sine of what gives you 1? 90 degrees, also known as pi over 2. So that's your answer. This is the only answer within that interval. So we're done. Okay. Let's now go move on to question 2, where we're looking at an inverse cosine evaluation problem. And we are asked to evaluate cosine inverse of negative square root of 3 over 2. Once again, our angle is in radians, and we're looking at the interval from 0 to pi. So how do we go about solving this problem? Well, just got removed for a second. Give me a sec. All right, much better. So it's asking cosine of what angle is going to be equal to negative square root of 3 over 2. Well, let's neglect the negative for a moment here and just look at square root of 3 over 2 in order for us to find our reference angle. And cosine of 30 degrees, also known as pi over 6, would give us square root of 3 over 2. So our reference angle is pi over 6. Now we're going to incorporate the negative. And so we want to utilize our all students take calculus, quadrant 1, 2, 3, 4 strategy to evaluate where is cosine negative, and more specifically, where is it negative and also lies between those bounds from 0 to pi. So 0 to pi is quadrant or are quadrants 1 and 2. However, in quadrant 1, all trigonometric functions are positive. So quadrant 2 must be our answer, and it is indeed because only sine-related functions are positive in quadrant 2, which would make cosine negative. So now what we have to do is we utilize our reference angle, that pi over 6, in that second quadrant to figure out what angle we are really looking at. And so once again, pi over 6 is about 30 degrees, so a third of that quadrant would give you that reference angle. And so that means that the angle we are looking at is pi minus pi over 6, which gives us 5 pi over 6 to be our answer. So cosine of 5 pi over 6 will indeed give us the negative square root of 3 over 2. And that's it, right? Let's now move on to the back page, question 3, where we're going to be utilizing some SOHCAHTOA here. Anytime you see a right triangle, you just want to write out this acronym because there's a really good chance you'll be using this. The question is asking to solve the triangle below, find the angle theta using inverse trig, and leave your answer in terms of an inverse trigonometric function. So what do we have here? Well, we have our angle theta. From theta, we have our opposite side. So O for opposite. I'm going to highlight that in yellow. And then our 10 is our hypotenuse side, which is H. And so of the information that we're given, we are going to be utilizing our sine function because we have both yellow and blue there. So we have sine of theta is equal to our opposite over our hypotenuse. And I'll, once again, maybe color code so you guys can see. And we know that our yellow is 6 and that our hypotenuse is 10, which can be reduced. We always want to put it into simplest form. So we have our sine of theta is equal to half of 6 is 3, half of 10 is 5. And then we want to evaluate what our angle theta is in exact terms. So we're going to have to utilize our inverse functions, and we're going to apply, we are going to apply inverse sine to both sides. And when we do that, that left-hand side, what do you think we're going to be left with? We'll just be left with our theta, which is what we want. And then our right-hand side, we have our sine inverse of 3 over 5, which is our final answer. Oops. Pen's doing crazy things this morning. And that's it. Finally, we're on to our question 4, where we are asked to find the exact value of cosine inverse of sine of negative 11 pi over 4. So we're going to first focus on what we have in the inside, evaluate that, and then work our way out. So sine of a negative 11 pi over 4, well, let's first look at the reference angle. We know our reference angle is going to be pi over 4, but let me help you visualize that as well. We have our nice little unit circle, and we know that each semicircle is 1 full pi. If we bumped that 11 pi over 4 to 12 pi over 4, we would hit 3 pi. And so what would that look like? It's negative, so we're going clockwise. So this is 2 pi, and then 3 pi is up to that x-axis, but we want to stop right before, oops, at 11 pi. So that, okay, let me try and do this when it's paused. All right, good. So right there gives us very clearly, we have 11, or negative 11 pi over 4. And then we can easily identify that this reference angle is going to be pi over 4. Okay. What quadrant do we end up in? We end up in that third quadrant. So all tangent related functions are negative here. I said negative, I meant positive. Everything else is negative, which checks out. We could have also utilized our knowledge of odd and even functions, and we could have just pulled out the negative and looked at sine of 11 pi over 4. But either way, you would obtain the correct result. So this is the same as just negative sine of pi over 4 because in that third quadrant, sine is indeed negative. And we know that sine of pi over 4 is square root of 2 over 2. So negative sine of pi over 4 is negative square root 2 over 2. Now we can bring down that cosine inverse. So what is this question asking us? It's asking cosine of what angle is going to give us that negative square root 2 over 2. And it's important to keep in mind when we are taking the inverse of a trigonometric function, we really need to utilize our specified bounds because taking the inverses of functions, we can only take inverses of one-to-one functions. And sine and cosine alone aren't one-to-one functions unless you have a restricted domain. So our bound for cosine is from 0 to pi. So we need to figure out, okay, what is an angle theta between 0 and pi that will give us that negative square root of 2 over 2. So once again, I'll draw another little unit circle on this left-hand side. Label my quadrants. We have 1, 2, 3, 4. And our acronym, all students take calculus. 0 to pi, I'll use the same color as the previous page, is going to be these top two quadrants. But we're looking for when cosine is negative. So it's not the first quadrant, it has to be in the second quadrant. Now, what is our reference angle to get that square root of 2 over 2? Well, it's good old pi over 4. So now what we're going to do is we are going to put in our reference angle pi over 4 in that second quadrant. So this is our reference angle. And this is the angle that is our official result. So pi minus pi over 4 will give us 3 pi over 4. Which tells us that cosine of 3 pi over 4 will indeed yield negative square root of 2 over 2. This is the only answer. Yeah, so it's really important anytime we're dealing with inverse functions, we need to take into account the necessary bounds in order to look at a one-to-one function. I think I'm just going to write it all out again. Give me a second. And there we have it. Great. Hope this was helpful. Let me know if you have questions. I'll see you guys next time.